We'll continue our discussion with rotor circuits. Rotor circuit of three-phase induction motor. Okay. In the last class, we have discussed about numerical problems. Okay. Now, what is the relation between stator flux, rotor flux? Okay. Now, okay, and all the relevant topics. Okay. Now, what is the effect of slip on all the different parameters like voltage, current, and the EMF induced? Okay. Next, now here we'll try to discuss the concepts of rotor circuit here. So we already know this for transformer. So I am trying to draw in short. Resistance, reactance, okay, yeah. So this is supply voltage V1 and this is secondary winding voltage. This is R2 X2, okay. Whereas in induction motor it is short circuit. Yes or no? So I'm just trying to represent in short. This is N1, N2, this is E2, okay. So here we are trying, now what we are going to do here, we are trying to concentrate more on the secondary side, that is rotor side. This is, we are trying to concentrate more on the rotor side and this is stator side here, okay. So what we discuss here, so the frequency here it is Fs, supply frequency, and the frequency here it is Fr, okay. What is E2? EMF induced in secondary side or rotor side, and under standstill condition. E2R is same EMF induced under running condition. Under running condition. This is what we discussed. EMF induced under the running condition. Okay. Now here, so with the same here, I can say that under running condition, here this is ER. Under running condition, EMF induced will be ER. Okay, ER we just represented in the last class, E2R. EMF induced under secondary side under running condition, E2R. Okay, EMF induced under secondary side under running condition. That is E2R equal to S into E2 here. I am only confining to the secondary side, just okay. Now here, under the secondary side, we already discussed that secondary side or under rotor side, this secondary, it is short circuit. Okay, now secondary side is short circuited and it is the EMF induced under running condition is E2R here. What is E2R here? S into E2. E2R is S into E2 times. S into E2 times here. Next, current is I2. Okay, I2 current is secondary currents. Okay, now I2 current is secondary current. Resistance is R2 and impedance is, previously it is X2, now and in transformer now I am changing into SX2 because X equal to 2 pi FL. Okay, now so that it is changed from X2 to SX2 here. This is the approximate, okay, this is the equivalent circuit under the secondary side or under the rotor side in three-phase induction motor. In three-phase induction motor. Okay, so I'll try to write here, that is I2R or I2 equal to E2R by Z2. Okay, now what is this I2R here? I2 is nothing but current under running condition equal to E2R by Z2. What is E2R here? S into E2. S into E2 here. That is equal to S into E2. S into E2, and the impedance is nothing but already E2R equal to S into E2 and impedance Z2 equal to R2 plus J SX2 here. R2 plus J SX2. This is the current formula. This is the current formula here. Okay. So what I'll try to do here, I hope it's clear. Shall I proceed? Okay. So I'll try to simplify the things here. How many S terms, where S stands for? Slip. S stands for slip here. So I'll try to reduce, make this circuit in the easiest manner here. So we already have S term in the two cases here, two different places here. So instead of that, what I'll try to do here, I will just try to change it to reduce the S term into single term here. Okay, how I am going to reduce that here? See here, we already have I2 equal to, okay, I2 equal to, we already have written that SE2 by R2 by J into SX2 here. So I am dividing both sides by yes. I am dividing both sides by yes. I guess everyone is okay, as we are all math students here. Okay, it's easy. So SS gets cancelled. Now here under denominator here, what is there here? It is R2 by S. I am writing here, that is E2, and in the denominator here it is R2 by S. Okay, plus SS gets cancelled here, plus J X2 here. R2 by S plus J X2 here. Okay, R2 by here, then plus J X2 here. Okay, this is what is I2R I2R here. I2R I2R. Okay, I2R I2R here. Okay. So now here, or else let me try to tell you in the other manner here. In the whole circuit here, what I will try to do here, I will try to divide it by, okay, now previously it was SE2 here, it is R2, this is JX2. I am trying to divide this by total S term here. Okay, so that if I divide this with S term here, then it is E2 and this is R2 by S, and here it is JX2 here. The same is represented here, E2 R2 by S plus JX2 here. Okay, E2 R2 by S, and here it is. This is the approximate simplified circuit here. Now where E2 stands for standstill condition. So I would like to represent this circuit in terms of EMF induced under standstill condition. Okay, now I am trying to represent this secondary side or rotor circuit EMF induced under standstill condition. Otherwise I can also say that I will try to reduce the this complications of S term in the both sides rather than simplifying into only in the R term here. So previously it was there in the both S as well as here. So now I am reducing it to, okay, only R2 by S term. Okay, I am reducing it to R2 by S term here. This is what I am doing in the simplification circuit. The question will be derive the equivalent circuit of 3-phase induction motor and with approximate equivalent circuit, finalized equivalent circuit here. So we need to do all these simplifications here. Okay. Shall I proceed? Yes. Okay. Yeah. So what I will try to do here, just I will try to rewind once again here what we discussed so far here. So this is an induction motor. What is induction motor is called as transformer with secondary short circuited. So what is induction motor here? Transformer with secondary winding short circuited. So whatever the features that are there with the transformers, can I able to represent here? Can I able to use these features for induction motor or not? So whatever the equivalent circuit that I am using for transformer, I can also use the same equivalent circuit for induction motor also here. Just only thing is, so secondary side is short circuited, rest everything is same. Secondary side is short, as it is short circuited, the secondary side or the rotor start rotating here to satisfy the Lenz's law here. Rest everything is same here. So we already know that this equivalent circuit in the primary side, okay, or else I can say that it is stator or primary. Okay, this is V1, I1, R1, X1, R0, X0. These are all what shunt branch parameters here. These are all shunt branch parameters, and this is, if you already know that, there is no need to draw again. Okay, now you already know this. Okay, now so this is series branch parameters. So there are no changes in the primary side. We should be least bothered about this primary side, and we need to worry more about this secondary side. Why? Because secondary side is short circuited. Okay, now secondary side is short circuited, we need to consider. Okay, now we need to concentrate more on the secondary side and what are the changes, as we discussed just now, that what are the changes that are done here. So we have simplified this equivalent circuits SE2 R2 JX2 into E2 R2 by S and JX2 here. Okay, so let me try to recollect the same here. So this is what we simplified here. It is E2 R2 by S and JX2 here. Okay, so now here, instead of writing this R2 by S, what I will try to do here, so I will try to further simplify for my calculation purpose or easy analysis purpose here. So this is the combined circuits for the primary as well as secondary. I hope you already know this. There is no need to redraw again. Okay. So just one only change here it is. The short circuit is extra. Rest everything is same here. Okay, now the short circuit is extra and the rest everything is same. Whatever we changed here. So I have represented in the secondary side. This is E2 R2 bias and E2 R2 bias and other one is JX2 here. Okay. Any doubts? I guess no. So what I will try to do here. Okay. So instead of R2 bias, I will try to divide this term into 2 points here. Okay, now what is the R2 here? R2 or resistance? It is always responsible component for the heat losses generation or I square R losses generation. Okay, now here we are referring S for slip. Okay, now S for slip is equal to Ns minus Nr by Ns here. So I would like to separate these two terms here. Okay, now I would like to separate the loss components and S components separately. So that what I will try to do here. I am rewriting here R2 plus R2 into 1 minus S by S. Okay, let's check that whether the equation is same or not. So R2 plus, if I simplify it is R2 by S or not. And next minus of S into R2 by S. SS gets cancelled. So here R2 plus R2 by S minus R2. Okay, so ultimately what happens here? It will be R2 by, so it will be R2 by S. So here again the answer will be R2 by S only. So even if I represent this equation instead of R2 by S, if I rewrite the equation in terms of R2 plus R2 into 1 minus S by S also, the circuit will remain same because I am just adding and subtracting. Just instead of R2 by S, I am adding rewriting the equation as R2 plus R2 into 1 minus S by S. Instead of single term, I am replacing it with two terms. Okay, I am replacing it with two terms here. R2 plus R2 into 1 minus S by S here. So what I am changing here, the same representing, I am representing here. This is R2 and this is R2 into 1 minus S by S here. Only thing we need to draw, we need to concentrate only on secondary side, not on the primary sides. Okay, not on the primary sides. Okay, so R2 into 1 minus S by S. So here what I have written here R2 by, instead of R2 by S, I have written here R2 plus R2 into 1 minus S by S here. Okay, so I am representing here R2 here and R2 into 1 minus S by S. So why I am doing this all? Okay, so one parameter. Okay, yeah. So we just now we have written here R2 by S equal to, is it clear or not visible? R2 by S plus equal to R2 into 1 minus S by S. Okay, so here what is my intention here? So let's try to convert this in terms of powers. So for that what should I do here? We know that P equal to VI and what is the other form here? I square R. So that I will try to multiply both sides with I2. So multiply both sides with I2 or IR, whatever it is. So I2 square into R2 by S plus I2 square into R2 plus I2 square into R2 into 1 minus S by S. Okay, I2 square into R2, I2 square into R2. Okay, so yeah, I guess I need to write again. same, okay. So R2 by S equal to R2 plus R2 into 1 minus S by S here. So I2 square into R2 by S equal to I2 square into R2 plus I2 square into R2 into 1 minus S by S here. Okay. So here, okay. So what is this term here? Where this I2 square, I am trying to represent directly here. This I2 square, okay. First we'll try to represent what we already know this. I2 square into R2. Is this a copper loss or not? This is a copper loss. So R2, secondary side or not? Or rotor side. Okay, so that can I write here rotor copper loss? Okay, this is rotor copper loss. So I am trying to represent here I2 square into R2 by S here. This is, I am writing here air gap power. Air gap power. Okay, so just keep this term aside for a few minutes. We'll try to discuss in detail. Okay, now air gap power is nothing but the power which is transferred from the stator to the rotor under standstill condition. If you want, you can write down the definition here. Air gap power is power transferred from stator to rotor through air. As the power is transferring in what manner? It is through air only. So that, okay, the power which is transferred from stator to the rotor through air under standstill condition. Under standstill, okay. The power transferred from stator to the rotor is called as air gap power. Okay, now. So as the power transfer is taking place through air, that's why it is called as air gap power here. So it is I2 square into R2 by S here. And what is this I2 square into third one? Okay, what is this I2 square into R2 1 minus S by S here? This power is called as gross mechanical power. Gross mechanical power. Gross mechanical power. I2 square into R2 into 1 minus S by S here is called as gross mechanical power. It's like for in your exam. So if the exam is conducted for 100 marks, you get somewhere 80 and losses are 20 marks. So this 100 marks is air gap power. Losses 20 marks is copper losses, and gross mechanical power is 80 marks. Okay, now. So this is all I am considering about in the which side? Okay, I am considering in the rotor side. Okay, I hope it's gone. So let me try. So this is what the importance here. So let me try to add here. So what we written here, I2 square into R2 by S equal to I2 square into R2 plus I2 square into R2 into 1 minus S. Okay. You might be asking, sir, induction motor is 3-phase machine. Okay, but you are including for only for single phase. What I will do, I will try to multiply all sides with 3. Okay, now for each phase. Okay, now. So how will you calculate the total power? So if you calculate each phase power, if it is a balanced supply, each phase power into 3. So even for 3-phase supply machine, induction machine, I will try to multiply with 3. 3 into I2 square, that will be the 3-phase power. Okay, now. That will be the 3-phase power here. 3 into I2 square into R2 by S, 3 into I2 square into R2 plus 3 into I2 square into R2 into 1 minus S by S here. I hope now you understood why I am splitting this term here. Instead of R2 by S, why I am splitting into R2 plus R2 into 1 minus S by S here. So instead of R2 by, instead of this, I am keeping it separate, this copper loss term separately, and here mechanical load, mechanical equivalent of electrical power, gross mechanical power separately. Is this clear or not? So this is the 10 marks question which they normally ask, that simplify the equivalent circuit of an induction motor. So you need to start from primary, just write down this, draw once the single primary circuit and simplify SE2, R2 and SX2 and divide it both sides with S time. Then it will be E2 and R2 by S and X2. And again convert R2 by S formula into R2 plus R2 into 1 minus S by S. And after simplifying that, you can rewrite this is the finalized equivalent circuits. Why I am all doing this? Because whatever the power that is there here, this is air gap power, and this power is copper losses, and this is mechanical power. The fan which is rotating actually, that is the mechanical power, the actual power. Okay, so we'll try to this is what the equivalent circuit of 3-phase induction motor, equivalent circuit of a 6-phase induction motor. I hope I am clear. Yes or no? So let's if it is clear, then we'll try to get back to this power flow equation. So power flow equation in 3-phase induction motor. Okay, power flow equation in 3-phase induction motor. Power flow equation in 3-phase induction motor. So